Yes, hello friends, welcome back to Pure Math School, and today I'm going to continue handling the 3 questions that I received from a friend that needed assistance. Last time I handled the first one, that was 2.1, and as you can see today, this one is 2.2 here. You can check the photo on the cover of the video, or the thumbnail of the video. So the one we have that we are going to face today says that to prove the following identity. Actually, it says 2 sine squared x out of 2 tan x minus 2 sine x cos x equals to cos x out of sine x. So we are going to start from our left hand side. Okay, our left hand side says that 2 sine squared x out of 2 tan x minus 2 sine x cos x. So we need to manipulate this left hand side to be just like that right hand side. So if you can observe on right hand side, we have on the numerator we have cos x, while on the denominator we have sine x. So we're going to do everything possible on the numerator to manipulate it to become cos x and the denominator to become sine x. So that means if you see our numerator right now, it's 2 sine squared x, but we need to manipulate that one to cos x. But you can realize that we have sine squared there from Pythagoras theory. You know that sine squared x plus cos. From Pythagoras theory, you know that sine squared x plus cos squared x equals to 1. So for that case, we try to make sine squared x a subject to substitute that. Sine squared x will be 1 minus cos squared x. Okay, I think you can be familiar with that. We have made sine squared x a subject. So what do? We can replace that there. So we're going to have 2 into 1 minus cos squared x. Okay, out of tan, we try to manipulate it to go to, we are trying to now manipulate even a numerator to have at least sine. So tan can be changed into sine x out of cos x, right? Then we have minus 2 sine x cos x. I think we are okay there. Let's proceed and try to see. Let's try to get the LCM. Let's not touch the numerator. First leave it there because we don't know what will come ahead of time. So let's see. If you can see here, we have the first expression 2 sine x out of cos x as a fraction, but the second one is not. So let's combine them. So that means we are going to have 2. Okay, let's first get the LCM of that. Will remain cos x for that denominator. So if it's cos x, that means here we're going to remain with okay, actually 2 sine x minus, there you're going to remain with 2 sine x cos squared x. Okay, I think we are still good there. Let's not yet touch our numerator. We have 2 into 1 minus cos squared x. If you can observe carefully, our sine x there, we have that 2 sine x is actually a common term. It's common throughout, but let's first try to flip that. Since it's a fraction, we can first flip it and try to take it up by multiplying by the reciprocal of that. So we are going to have that 1 times cos, the reciprocal of 2 sine x minus 2 sine x cos squared x will remain cos x up out of 2 sine x minus 2 sine x cos squared x. Okay, what next? That will still remain like that. 2 into 1 minus cos squared x out of 1 times there cos x out of what do we have there? We see 2 sine x being a common factor. Factorize it out, remain with 1 minus cos squared x there. Okay, you can see that we have 1 minus cos squared x up and as well down. What does it imply? Those two will cancel out, so remain with 2. Even 2 is going to go because you see 2 there and here, so actually remain with only 1 out of 1 times cos x out of sine x. So we end up saying that actually we remain with only cos x out of sine x. Okay, therefore the whole of that there, we had 2 sine squared x out of 2 tan x minus 2 sine x cos x, and given by that as required. So thank you for coming to the channel. Please let me know if you have any other approach to the question in the comment box. I'll be so grateful, and we can share the knowledge together. And please don't forget to subscribe and like the video in case you enjoyed it. Don't forget to subscribe to the channel and hitting that notification bell. By doing that, you'll be updated every time I make new uploads. Thank you. Bye. Please see you in my next video.